Welcome to the topic of conservation of momentum. The image we have here illustrates a car being crash tested. Looks like it's in Europe, and we see a crash course, a crash test dummy inside. Momentum is tied to this whole idea of cars and impacts. And momentum itself, as a concept and as a field of study in physics, is perhaps the most important idea we will encounter. What we will see is that it dominates and drives almost everything that goes on with motion of objects. So momentum is important not only in terms of understanding motion, but it's important in terms of designing and engineering systems to keep people safe. And so in this particular case, we see airbags and crash crumple zones and so forth testing cars. In this lower picture, we see boxers. It turns out momentum and the concepts related to momentum relate to how we use padding for athletic endeavors and how we can reduce injury and a great number of other aspects to motion. So, momentum itself has a number of related concepts. One of those is impulse, that we'll see. But momentum really is the topic that allows us to answer questions like, why do objects change their motion? What are the concepts that govern the change of objects' motion? What are the rules or principles that govern the change of motion? And in a larger, broader international context, something that ties all humans together, how does the physics of momentum and impulse affect our daily lives? And we've already seen that on the previous page. So let me put you into a little bit larger intellectual context here. If we take the entire range of things that relate to motion, one aspect of motion is kinematics. And kinematics is about, it answers the question, how do we describe model and predict motion? It is in its essence descriptive. And we've already studied kinematics. And we have our fundamental concepts in kinematics of position, of velocity, of acceleration, and of jerk. So those are our four concepts we use to deal with kinematics. Well, so how do we describe, model, and predict motion, the descriptive element? Well, the next part of motion that we're moving into here is dynamics. It's why do objects move and change their motion the way they do? Now, it turns out there's really two fundamental sets of rules and laws that govern this. And the first one is momentum. And the second one is energy. And of course, this topic we are beginning is momentum. And why these two are so important and they drive everything in dynamics and the reasons why objects move is because of the law of conservation of momentum. And with energy, it's because of the law of conservation of energy. And so it's really the law of conservation of energy and the law of conservation of momentum that allow us to predict and describe and explain why all objects move the way they do and allow us to predict them. And that's what drives everything. And so in the field of momentum, what we are going to learn about, of course, is momentum, but we'll also learn about inertia, and we will learn about impulse. And those are the two main ideas in impulse. And I guess we should add the rate of change of momentum which is delta P over delta T. And that happens to be the definition of force. So the idea of force comes out of momentum. So we have inertia, impulse, the rate of change of momentum. And so, of course, then that leads us to this other powerful tool and perspective for looking at motion, which is force and forces. Now, energy has related concepts that relate to force as well. But primarily, why objects move the way they do is about the law of conservation of momentum and the law of conservation of energy. Now, toward understanding our entire topic of momentum, we've broken it down into several little mini lessons on linear momentum, change in linear momentum, impulse, the rate of change of momentum, the law of conservation of momentum, and what grows out of those is Newton's laws. And then we'll look lastly at a number of applications of linear momentum. So along the idea of momentum, there is an older idea than momentum that precedes it and is related to it, and that is inertia. And if we were to define inertia, we would say it is a body's ability to resist a change in motion. Now, we tend to think of an object having inertia when it's already moving. You know, it's already in motion and it kind of wants to stay moving type of thing. But it is also true that an object that is not moving wants to resist any change in its motion. And so by that token, a change in motion means a change in velocity. That's what's meant by a change in motion, a change in velocity. If we change the position of something, there must be velocity involved. It will go from zero velocity to some other velocity. But the big deal about inertia is that it depends only on mass. Inertia depends only on mass. And so then we might want to define what mass is, since it depends only on mass. And mass is the amount of matter in a body, and it is not weight. And of course, to remind ourselves of that, we could picture being, quote, weightless in space. Now, if we're weightless in space and we come down to Earth, we don't all of a sudden take on more matter. The amount of matter we had is the same, but what's happening is our weight will change. And so that's an important distinction there. Now, when it comes to mass, there are two different ways to determine mass. One of them is to determine the mass gravitationally. So we call that mass the gravitational mass. And the gravitational mass is determined by observing behavior in a gravitational field. So we take an object, we may not know its mass, and we observe its behavior in a gravitational field, and from that we then can determine what its mass is. The second way is by using inertia, and that is determined by observing behavior when interacting physically with other bodies. And we can think of collisions, for example, things colliding or hitting each other. That's a simple way to think about it. And so, as an outgrowth of all those concepts, we come to a very, very famous statement that most school children in the United States and perhaps even the world over can recite, and that is that an object in motion tends to stay in motion, an object at rest tends to stay at rest unless acted upon by an outside force. But what does that actually mean? That is a statement of Newton's first law, which is what I abbreviate and many abbreviate as N1. Newton's first law of motion. And Newton's first law of motion then relates to inertia. It's called the law of inertia. An object in motion tends to stay in motion. An object at rest tends to stay at rest unless acted upon by an outside force. But in truth, if we were to really summarize this and break it down to its essence, what this really says is that all bodies tend to maintain their current velocity. So if something's at rest, it wants to stay there. It wants to keep that. If it's moving at 40 miles per hour, it wants to keep moving at 45 miles per hour. And it will maintain that velocity forever unless there's an outside force acting on it. The natural state of objects is to preserve their state of motion, to maintain their current velocity. And that is a very, very important concept for us to hold on to. So that ends our introduction to momentum by way of inertia. In our next lesson, we will take a look at linear momentum.